Hello everyone, welcome back to my YouTube channel. This is Anish Kumar, and today the topic which we're going to discuss about is relational model in database management system. So without any further delay, let's just get started. We have many interesting things to cover up in this session. So firstly, we just get started with what a relational model actually is, like a few introductions, a few examples of what relational model actually is. Then we look on to the key terminologies that are used in a relational model. Then we'll see what are the characteristics. Then we'll just shift on to the advantages and the disadvantages, and after that a few important things based on the relational model, such as the domain constraints, the key integrity, and referential integrity. We'll just look on to them later. So firstly, let's just get started with what a relational model actually is. So the relational model represents how data is stored in relational databases. So data, as we all know, is like a collection of certain information, right? Like, and if all this is merged together, all these data is merged together, then it makes a database. So we just have to see here, like what a relational model actually is like how it is related to each other. Like all this data is related to each other in the database. A relational database consists of a collection of tables, each of which is assigned a unique name. So as we can see here, like the roll number is different for all the entries here. All the data have different roll numbers. Like Ram has roll number 1, Ramesh has roll number 2, Sujit has roll number 3, and Suresh has roll number 4 here. So yeah, they have different ones. It can't be like they actually duplicate, because that won't be a case. Then their database will be faulty if two students or two people will be having the same roll number. And yeah, so next up, like consider a relation student with attributes roll number, name, address, phone, and age as shown in the table. So these are the attributes actually. So attributes will know what an attribute actually is. So this is how, just for example, just see this is what a relational model actually is. Like, yeah, further, let's see what are the key terminologies. Like I just used this term attribute. What are attributes? Attributes are the properties that define an entity. Example, roll number, name, address. Attributes can be like anything that define a certain thing. Like gender can be my attribute, and my name can be my attribute, and my phone number, okay, not exactly, but yeah, things related to that. Like roll number, it's unique, it's just for me. So yeah, these are the attributes that I have. Next, relational schema. A relational schema defines the structure of the relation and represents the name of the relation with its attributes. Example, student. Student has all this relational schema: roll number, name, address, phone, and age. So all these are the relational schemas of the student. Like roll number, a student obviously will have a roll number. Student will obviously have a name. uh, like student obviously has a place where he stays, and then phone these days, like it's very common. And yeah, student has an age. Like this is the relation schema for student. If a schema has more than one relation, then it's called a relational schema. So tuple, we've actually come across this term in Python, but no, this is a completely different thing. So each row in the relation is known as a tuple. So in Excel, like rows and columns, we deal with rows and columns, right? So exactly in databases, row is nothing but a tuple. The above relation contains four tuples, one of which is shown as you can see, there are four tuples. If we exclude the roll number from here, there are four columns: Ram, which is the name; Delhi, which is the address; and this is the phone number; and 18 is Ram's age. So these are the four tuples of this certain entry here. Next up, relational instance. The set of tuples of a relation at a particular instance of time is called a relation instance. So yeah, at a certain instance, when we are like checking for tuples, then we get a relational instance. Table 1 shows that the relation instance of student at a particular time. It can change whenever there is an insertion, deletion, or update in the database. Like yeah, obviously when there's a new entry, the roll number size increases. Like there are totally four here now, but if there are any new entries made, then there'll be 5 or 6 or 7 based on the number of entries. And if there are any entries deleted, then yeah, the numbers decrease. So next is degree. The number of attributes in the relation is known as degree of the relation. So let me get back to the slide. So here, as you can see, it has the degree 4 here, because name, address, phone, age, and yeah, if we consider the roll number 2, then the degree will be 5 here. It has 5 attributes here, so it will make the degree 5. So let's see what it actually says. Yeah, as I told, the student relation defined above has degree 5 because it has 5 rows, like 5 attributes in it. Cardinality. The number of tuples in a relation is known as cardinality. Like we'll see how many total number of tuples are there, and that will tell us the cardinality. The student relation defined above has cardinality 4. Column. The column represents a set of values for a particular attribute. The column roll number is extracted from the relation student. Characteristics of relational model. Data is represented in rows and columns called relations. Data is stored in tables having relationships between them called the relational model. The relational model supports the operations like data definition, data manipulation, and transaction management. Each column has a distinct name and they are representing attributes. Each row represents a single entity. Well, you can't actually uh, have multiple entities in a single row. One row will only like represent a single entity. Like, let me get back to the slide again. Example Ram here. All the like all these things, Ram, Delhi, 94555, blah blah, and then age 18. All this is related to Ram and Ram only, not anyone else. So that's what it is. And next, we'll just move on to the advantages. This is a very simple model actually. As you can see, it's a very basic table of rows and columns. A relational model is simple and easy to use in comparison to other languages. It is very flexible too. It's more flexible than any other relational model present and at present time. But yeah, there can be advancements in the future. We can get even the simpler ones. But for now, this is the simplest one and the most flexible one now. Secure. Relational model is more secure than any other relational model. Yeah, even the security is a major concern these days. And this is a very secure model. Data accuracy. Data is more accurate in the relational data model. Data integrity. The integrity of the data is maintained in the relational model. Operations can be applied easily. It is better to perform operations in the relational model. Disadvantages. Like everything comes with pros and cons. And yeah, the relational model also has a few disadvantages. Like it is not very good when it comes to large databases. When example, consider the population of India. When someone has to like keep a track of all the people in India and they have to like put it in a database, then it's gonna be a very hectic task. And yeah, I don't think, okay, yeah, the relational model is not capable of handling such big databases. Sometimes it becomes difficult to find the relation between the tables. Because of the complex structure, the response time for queries is very high. Queries is nothing but the questions whatever you ask. Like you see a certain table and then you actually ask for the phone numbers of all the students there. Like example Ram, whatever I told. If you want Ram's phone number, then yeah, you can actually ask a query for that, and you can extract that certain data from the relational model with the help of queries. That's what it is. Next up, domain constraints. Domain constraints specifies that within each tuple, the value of each attribute must be an atomic value from the domain. Whenever we have a tuple inserted into the database, the tuple should be a simple value from the specific domain. These are attribute level constraints. An attribute can only take values that lie inside the domain range. Example, if a constraint of age greater than 0 is applied to the student relation, inserting a negative value of age will result in a failure. Like, yeah, age is actually something that is positive in number. It can't be negative. But yeah, if there's a certain guy who's very notorious and if he's putting his age in negative, then yeah, that might actually cause problems. Like, that might go out of the constraints. Constraints are nothing but the boundaries. You can't actually go out of your boundaries, right? I mean, now the motivational talk, like, yeah, the rules and restrictions, you can't just be violating them. Just like that, the constraints are like the boundaries here. You can't be like going out of them. Key integrity. Every relation in the database should have at least one set of attributes that define a tuple uniquely. Those set of attributes is called keys. Example, roll number and student is a key. No two students can have the same roll number, so a key has two properties. It should be unique for all tuples. It can't have null values. Like a student can't, like it can't be possible that a student doesn't have a roll number. Then he isn't a part of this institution. Like whatever his institution is studying in, he can't be a part of that if he doesn't have a roll number. So it can't be a null value and it has to be unique. Just two simple things. So finally, we'll end the session with this final topic, referential integrity. When one attribute for a relation can only take values from another attribute of the same relation or any other relation, it is called referential integrity. Let us suppose we have two relations. Branch code of student can only take the values which are present in branch code of branch, which is called referential integrity constraint. The relation which is referencing another relation is called referencing relation. Like it references the other relation here. So that's what referencing relation actually is. Student in this case. And the relation to which other relations refer is called reference relation, branch in this case. So yeah, this is what it is. Like we have two tables here. So we've seen the first table before, and you can see like Ram here has a branch code to the branch in which he's studying in. So CS is his branch, and just by that branch we can actually access that. This actually references an other relation here, like the branch code. With the branch code we can actually like get to know what his branch name actually is. So this is all about the relational model. Hope you all liked the video. If you liked it, kindly click on the like button, subscribe, and kindly share. Thank you. That's all it was for today. Have a good day.